you have questions, you can put them in the chat if your internet will let you do that, or whatever you can manage. Right, let's make a start. And did the recording start? Let's see it. Okay. Right, morning everybody. Welcome back. Thank you for coming back. Brave of people to come back. I know yesterday for some people might have been quite a lot, quite a stretch, but it's worthwhile, you know, no pain, no gain. So thank you for coming back and picking this up again on day 2. For those who have just recently jumped into the meeting, I mentioned that yesterday I would usually have done an introduction thing and asked people to pop in the chat their name, their organisation, and, you know, a sentence or two about what your background is with coding, whether you've only been really working with Excel, Power BI, that kind of stuff, or whether you've been doing SAS or whatever other coding history you have. Just to introduce yourself and get an idea of who else is in the room. So if you want to do that today, please feel free to do that and just say hello to your fellow cohort, which might be quite useful for you. You might see people who you might want to reach out to. But what we'll do today is we'll pick up roughly where we left off. I'll do a quick précis of what we covered yesterday, just to remind you, because we start off day 2 basically back where we were. So we'll need to make sure that we still have the relevant data loaded and all that kind of thing. So let me share a screen and I will wake up my project. Let me just get rid of all the other gubbins I've got on my computer so that you don't get distracted by my Teams messages. Right, okay. So let's jump straight back in, shall we? And again, today, please, again, the best bits of yesterday are when people have a problem, they come on, they share their screen and we work it out together. Those, generally speaking, are the most valuable bits. So if you're having a struggle with anything or want to share your screen and ask questions, then please do. Those are really valuable. Really, really like it when we all help each other debug. Right then, so for those of you on Posit Cloud, as you saw when I logged back in, my intermediate R training project had gone to sleep, so you just click resume and it should come back up, come back to life for you, or you can go back into RStudio if you were working there. And again, let's go back into our Intertrain student version, which is in your files, back to where we were, Intertrain student version.r, which is the R script that we were working from yesterday. We got to roughly here, which is line 1026, so well done us. But let's go back very briefly. You don't need to scroll back up with me. I'll just go through very briefly what we talked about yesterday as a reminder. Have some water first. We'll do the same thing today if it worked for everybody as well in terms of timing of breaks and whatnot. If we rush through all this, we might have time to go into other stuff at the end. But if the breaks were a decent time for you yesterday, then we'll just do them again. Right, so yesterday, what did we do? We loaded a bunch of packages that we needed, and we used a nice little bit of code to check whether we'd loaded the right ones and load them if not. We went on to look at some base functions using AE attendances, AE_attendances dataset, which is found in one of the packages that we loaded. So we used some interesting and useful functions like names, column names. We indexed using the $sign, which told us the elements within an object. We used unique and we indexed based on position as well. And this is position within a column, both for a single data point and for a range of them. And we pointed out the differences between Python and R in that respect. We used the n__ distinct, which can give us the number of distinct levels of a factor, which is useful. And some other useful bits and bobs like range, structure, str, head and tail. And we talked about how you can modify head and tail to get it to give you the right number of rows back that you want to see. And top fraction as well, which is a useful version. Top n and top fraction are quite related. And we can do this to get the top X% to have a look at that in the console. Then we moved on a little bit to look at some summary statistics. So the table function, which is a really useful, simple one, is very useful for doing a 2x2 table to understand the distribution of your variables within your data set. And you can do it by 2 columns easily by feeding it as different arguments to the table function. But beyond that, it gets a bit messy. We renamed some columns. So a lot of what we did yesterday used dplyr, which is the library that exists within the tidyverse library. Mega library or whatever it's called. So we renamed things into nice ways of naming the columns within a data frame. R doesn't like spaces. We don't want there to be a mixture of uppercase and lowercase. Tends to be with the R what we like to do, unlike with SQL and other languages. We like everything to be lowercase, and whatever way that you like to structure your names, whether that's camel case with the first one as a capital letter, or snake case, which is what we use here, you can apply that throughout. It makes it easier to read. We introduced the janitor package, which has got the really nice clean names function. And that clean names function, everyone I know uses it, because we all have to deal occasionally with Excel type data and or SQL outputs as well that like to have capitals and whatnot. So to fix all of those in one, we just pass it the data frame and it'll do all that work for us, which is really nice. Did a bit more renaming there. Then we looked at select from dplyr, and select in dplyr is all about which columns do you want. And we can do with select, we can pull back just certain columns. We can also use it to rearrange the order of the columns. And we can easily do that based on some arguments as well. So we can pass it the dates that we want, the columns that we want, and rename them on the fly. Remember this useful thing where the new name comes first and the old name of the column comes second. So that's helpful. And we can use the exclamation mark, not just here, but in lots of different places, to negate the statement that we've given. So this would be select not organization code and period. And we introduced the where clause and the contains as well. Contains and where are very useful to be embedded within other functions, as we've shown here. So that was nice, using select in that way. We joined some data together, which some of you will have found dead simple and dead easy, and some of you might have gone, hang on, what? So we did joins without a key to start with. So we just smushed together columns, or we smushed together rows, irrespective of whether they kind of matched up or not. And then we used bind rows as well to do so. And what do we go on to then? Then we started piping things together. So we used a lot of the new pipe syntax to string together different functions in a recipe. That if you're on the introductory course, we started talking about recipes as things like, you know, making mashed potato. Was it mashed potato we made? I think it was mashed potato, where you get your potato, you peel your potato, then you do this, then you do this. And so setting your code out on separate lines with the pipe operator on to differentiate those elements of your recipe can make it really nice and human readable. What do we do next? We looked at combining these things, looking at the differences in sets of elements. So using union and intercept and set diff, which can be really, really helpful. We did some grouping and ungrouping, and we got introduced, if you hadn't seen it before, to the new-ish type syntax that Tidyverse uses to group by. So instead of the old one where we have to group by and then remember to ungroup, we can group by on the fly in summarize with a .by argument, which makes it nice and quick and easy to do that, and you don't have to worry about ungrouping deliberately in that case. We looked at count functions. I'm going to skip through that quite quickly. And then we did fancy filtering. Fancy filtering wasn't very fancy, but we did some filtering. And filtering in the dplyr universe is all about selecting certain rows that match certain conditions. And we can give our multiple conditions that the rows that we want to pull back need to meet. And we can combine them in all sorts of different ways, which is quite nice. We have here. We use mutate a fair amount as well. Mutate is the way that we create new columns based on certain things. If we've got a lot of different cases that we want to evaluate within making that new column, then we can pass a case when clause to mutate statement, and so we can specify exactly which rows need to have which values in our new column using the .default for everything else, as it were. Then what did we do? We went down to, oh yeah, so we started looking at the if statement as well, which is a base R, very useful trick as well, to run a number of different elements within the scope of the if statement if this evaluates to true. And we saw how that can change things in the global environment as well. And so even if you run the same code twice, it might produce different output, and that might be what you want. That might become useful later on today when we start building our own actual functions. We made some subtotals. We created percentages on the fly, which it again started to look a little bit ugly, but it was, you know, I think probably everyone in the course was okay with it, which is great. You got the point anyway, which is more powerful than a lot of languages you might have used before, where we can use columns that we've created within the same mutate statement, we use the columns we've just created to do some further analysis, some further calculations. We use row-wise, which is where every row is essentially its own group. And so instead of, if we're getting a sum of something, sum as a function would usually look at a column. But if we run row-wise first, we'll be doing the sum of the row elements that we tell it to do. And with row-wise, because of the idea that it creates a row per group, we have to use ungroup afterwards. We then did some pivoting, wider and longer. I don't feel like I explained the pivoting very well yesterday, so apologies about that if you feel like you're a little bit unclear on why we would do it or how we do it. But you were given some examples and you played around with it, and hopefully you can see why we would do that and how that's quite useful. The syntax is quite good as well. It's quite clear and English readable, as it were. So pivoting is something that you'll end up doing probably quite a lot in your data munging lives. We looked at rolling functions as well using the zoo package, which is a nice little package to do these. And we can specify how we want to do rolling means or medians or whatever else it is that you want. So that's often really helpful with time series data, which is a common thing that we have too. And the last thing we did was this one, right? Yeah, well, row numbers. We use the row number function to very quickly use the row numbers that aren't exposed within the actual data object naturally to make a new column of those. And those are a useful thing to do in lots of different cases. And we introduced you to dense rank and these other kind of ranking elements too. Where did we go to then? Right, so this is where we are now. We're down to line 1026. So I'll pause there. Lauren, have you got a question?
Yeah, just before you do much more, can you zoom in a little bit? I don't know if it's that I'm on a different screen, but it's just on the edge of legibility. Thank you.
Sorry, yeah, not a problem. Thanks for asking. So all of you will probably know that you can change the look of your RStudio to make it as easy on your eyes as you like. So I generally have a white background when I'm teaching, but I work with a dark background and a dark theme. If people would prefer me to switch to a dark theme today, then we can do that. I want to make sure that everybody can see and it's not causing issues for people, the kind of color schemes that RStudio is using by default here. So I'll leave it to people to pop their hand up if they want me to play around with that a bit. Right. So has everybody managed to get back into their intermediate R training project, be that on Posit Cloud or within RStudio? Is anybody struggling to do that? Everybody with me and in the right place just now? Cool, good. Thank you for the thumbs up. Right, so let's start by grouping by dates, okay? So I reran everything above this this line this morning to recreate all of the things that were in our environment. Just there were too many here, it's a bit ugly, but just those that we don't have to go back and reload the data and everything. So if you haven't done that yet and you've got nothing in here, then I would suggest going back and rerunning the code above line 1026 just to get back to where we were. So let's do some grouping. Oops. Grouping by date and year to get to totals. So what we're going to do right now is we're going to create a new object within our environment called data year. We're going to do this by taking the data frame called data. We're going to choose the rows in which the organization code is RQM. I have no concept of which places these codes are, so please don't ask me, no idea. And we're going to specify that we only want where type is 1. Then we're going to group by, so this is the older syntax here to make it more clear. I'm going to group by, and we're going to create something called the year total. So we're grouping by and creating something on the fly, which is nice. I'm going to use this function called floor date. Now, you might be aware of floor date. Let me F1 it. So remember, if your cursor is clicking on flashing on a function, you can just press F1 and the help file should come up. So let's see what it says about floor date. Floor date takes a date time object and rounds it down to the nearest boundary of the specified time unit. So let's see that in action. So we want to get floor date of period, which, as we remember, with our data set, period was the time series column that we had. And then we're going to summarize, and we're going to create 3 summaries that are going to be for each group. Okay, we're going to create the total attendances, which is going to sum the attendances, total breaches, which is going to sum the breaches, and the median of the admissions. which is going to create, obviously, the median of the emissions. Now, we're using, again, this NARM, NA.RM is true, to not try to take a median of all the numbers that also include missing numbers, because it'll just fall over. So we have to hand the median this element too. So let's Control Enter on this and see what we get. Data year is... So as expected, we've got the year total, we've got the total of attendances, breaches, and the median number of emissions for each of the minimum dates per group. So do you understand what I mean by the minimum dates per group there? So this is why we've got floor date in here. The year total is the lowest date that happens within each of the groups, within each of the periods. Okay, so that worked relatively well. So we can also do a financial year. I don't really work in financial years, or try not to anyway. You guys might. So again, same filtering of rows, but we're going to make finance year. And we've got a little function here that I think was probably created because Simon had a question from the public in a previous one saying, how would we do that? So you'll remember that earlier on yesterday, we had an if_else statement above. There is also if else with no statement. If I F1 on it, you'll see it comes from base R. Okay, so it's a different syntax ever so slightly, but a similar way of working. So with an if else statement, the first thing before the first comma is the evaluation that you need to get as true or false. So if the month of the period is more than or equal to 4, the year of the period, so what we're going to get back then, if that is true, is the year of that period entry plus 1. Otherwise, the year of the period without +1. So these month and year functions come within the Lubridate package, which hopefully we have already loaded. I can't remember if we have or not. If not, we'll do it in a moment. So month gives you the month as a numeric. So it gives you a count, so January 1, February 2, etc. So what we're taking is for each of the, bring data back. For each period, if the month number is more than or equal to 4, so if it's April or later, it's the new financial year. So we're going to take the year that comes from here, so 2017, and add 1 if it's after April. So it's the next financial year. That makes sense? Let's, run the data finance. So we can see here that we've got the finance year according to the date. So let's see one on the edge case. So we've got a 2016 here. Can you see that? I'll zoom in again. Ooh, where did it go? Yeah, 2016, April the 1st of 2016 is actually in the 2017 financial year based on this code. And so if we just pulled out the year, it would give us 2016. But we know we want to be in the next financial year because we're after April. So we can do that with this if-else statement quite simply there. Any questions on that? That worked as expected?
I've got a silly question that's more about financial years. So is it standard if you're talking about financial years to use the later one at the end?
I honestly don't know. Anyone in the room got an opinion on that? Again, I don't work with financial years. They're scary. The world works in calendar years, which is what I work in. Does anyone have an opinion on that? I guess it doesn't really matter as long as you are careful within the data that you're creating, that you know what is consistent. And if you have a data set that has financial year in it, you provide an explanation of what you mean. So with any data that I send out, that we send out, we always have a data dictionary, which explains, even if it seems like it should be dead obvious that the organization code is the hospital code or whatever, we still have it written down in plain English. So for this, because people generally expect a finance year to be 1 year / the next year, here we've only got 1 year. So I would be specifying, by the way, this means the first year of or the second year of the financial year. Somebody put something in the chat and I didn't see what it said. Was it a financial year related comment? Published data 24/5 will be 25. There we go. So yeah, so Ella says that you use the second year. Maybe that is standard. I don't know. As long as you know what you've done and you use it consistently and you communicate that, should be all right. Right, so straight away this morning, we've got a little bit of work for you to do. So let's create a data frame that contains a summary of sites RF4 and RQ3 and returns the maximum number of type 1 attendances across those sites by financial year. He said, yes, that is a ridiculous question. It is rather, but it uses quite a lot of the skills that we've built on from yesterday and what we've seen just now. So over to you. Have a go at that. My clock says 9:23 at the minute, so I'll give you till well, I'll give you maybe 5 minutes to do this because it's a little bit involved. Any questions before I send you off to do that? Nope. Cool. Okay. Good luck. I'll put the instruction in the chat as well because I'll need to stop sharing the screen for a moment. And as usual, can you give me a thumbs up once you've got there, if you think you've got there? How are you getting on? Anyone got there? Well done, Lauren, you're flying today. Anyone struggling? Okay, we've had 5 minutes, so we'll bring back together. It is a tricky one to do first thing in the morning, right? Still only, it's not even 9:30 yet, so well done for having a go. Has anyone managed and wants to share what their solution was? It's fine if not.
I can share it. It might not be right, but if you'd like
Does
some
it, does it
audience
do the thing?
participation.
Go for it. Thanks, Lauren. Amazing. Please do. You want to talk us through it? If you control and roll and zoom in a little, might help. Cool. That's grand. So you want to talk us through what you've done?
Sorry, didn't unmute myself. So I created an object called data finance from data, filtered by the organization codes that were up there, using in and by type 1, and then essentially copied the code from up there for the financier, and then grouped it by the organization code and financier and piped that in to summarize creating max attendances using the function max of the attendances.
Brilliant. That looks great. I think that will do exactly the right thing. Anyone want to comment on that? Anything anyone's done differently? Cool. Leading the way. Brilliant. That does look great. That is what I would suggest. So little variations that you could do with this is you could have the dot by within the summarize. So because at this point you would have to ungroup again to make sure the data finance object doesn't stay as a grouped object. Might need to be, and that's absolutely fine. But that's one thing you could think about. The other thing I'd mention is I don't know whether the attendances dataset column has any NAs in it. So max, if it did have NAs in it, it would bring back the NA rows as your max instead. So if it doesn't, then that's great. But that does look correct to me.
I reckon there probably are some NAs.
No idea. Haven't looked. But that's brilliant. Thanks so much for doing that. That's awesome. Okay. Well done, everybody that got to that answer. Again, we're waking up the brain cells this morning still. Caffeine is kicking in. Right then. So moving on. We're now down to cutting up strings and parsing numbers. So we need to get more information out of our data. Our org code contains numbers and letters, but what if we only want to pull out the numbers? So we're going to do a lot of bits and bobs with strings at the minute, because a lot of your tasks when you're creating your data and making it nice and clean is going to be working with strings. So we'll show some of the ways we can do that. So let's create yet another table. I don't usually create a million tables with slightly different names. I try not to anyway, because it gets very busy. But we're doing it here just for clarity of understanding. So take the data set and mutate, create a new column called organization code number. And what this is going to be is we're going to parse number from the org code as a character. And we're going to say NAs is a combination of any and nothing. So let's run it and see what happens. And as expected, we get a warning here. Not an error, it's done something. It will have created the org code numbers table, which we can see here, but it's given us a warning, and it's warning mutates saying the org code number, blah, 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 has had parsing failures. So we could run problems for more detail, but we'll not bother at the moment. So it throws up a warning because the number of org codes don't have numbers in them. So what we're saying is we want to get the number out of this thing, this string. Why do you think we're passing it the as character first? We're wrapping the org code in as character. Any ideas? No? Let's have a look at what org code is in terms of its class. So org code is a factor. And a factor is a particular data type in R that has levels that have labels on them, essentially. What we want to do is to not treat this like a factor when we're parsing a number out of it, because what we're doing then is we're treating it as if it is just text. And that's what we want to do. And if we want to treat it a factor or what would be a numeric as text, then we can wrap it in the as character function. And that will temporarily, it won't change anything about the base data, but it will temporarily use that column as if it were a character column. And we'll need to do that here because we want to pull out a particular character, set of characters from that string. So parse number, let's have a look at where it comes from. It comes from the readr package, which is an interesting one for us to use. So we've run that already. So it's dead easy to pull out bits of strings as well. We'll go through a few different ways. Maybe we want to filter our data to any organization code that contains an R or a P anywhere in the organization code. We can do this using filter to say that we want a subset of rows, and the string detect function, which is a really, really useful one that I use a lot. The stringer package has got loads of useful, obviously, string-related functions in it. The more you do with text, the more you'll need to use this. And string detect does what it says on the tin. It's going to detect within the first argument to give it. So we've given it the column org code. And I want to detect the pattern R, which is just one letter R. Then we've got OR. Remember from yesterday, that straight uppy downy line that's near your shift key, the pipe as it's called, denotes OR. So I want to string detect either take rows where I detect the string R or where I detect the string P. So let's run this and see what we get. And here you can see in the organization codes, everything has got either an R or a P in it. And I think almost all organization codes do start with an R, don't they? Or was a P there somewhere? Yeah, so this one's got P here in the middle of it. So we're confirming to ourselves that all of the codes are coming back with either an R or a P. So the string detect is just looking within it. What organization codes have a number in them that's over 50? So can you return a data frame with just the organization codes of those with a number over 50? So have a think about how you might do that. You might need to do a bit of Googling to figure out what might be the best function to use for that. And there will be a lot of different ways of doing this, but just spend 3 or 4 minutes having a go at understanding how you could pull out just the numbers. And we can see that there are numbers in a lot of them, not all of them. There's numbers in a lot of them. Right, have a go with that. Any questions before we start off with that? Okay. Right, 9:35. I'll give you 3 or 4 minutes. Again, I'll put this in the chat so you've got it there. Has anyone managed to figure out this one? trickier, isn't it? It's extending you a little. Right, let's come back and we'll go through it anyway. And apologies, there's some noise in the background now. Someone's cutting the grass and my dog is having a nightmare. So if you're hearing strange noises, I do apologize. Right, I'll share my screen again. We'll come back and we'll talk through this one. So let's start off making yet another data frame to, we'll overwrite that one. And we'll say that data frame is data, then make a new column with the organization code number. We can use the parse number that we just showed you. And again, we'll wrap the organization, sorry, throat's going in, organization code in an as character, so that we're making sure that we're not using it as a factor. Any is a combination of, what did we say? So what we're saying with this one is sometimes in this org code column, NA is written as a string, NA in capitals, and sometimes it's written as nothing, the whole word nothing. So that's another important and common data cleaning process that you go through. So here we're saying NAs are anything that says NA or nothing, and it will take the usual NA as standard. So we've already done those bits. And then what we're going to do, where have you gone? You've gone from the screen. Then we can just use our filter again, can't we? So we're going to say the organization code number is over 50. So we had parse string above somewhere, didn't we? Parse number here. We've got parse number down here again. So this should be fine. Not over equal to. Yeah, okay. So that's probably how I'll do it, except without that silliness. Okay. Did anybody get something like that? Are we gonna many failures? What's going on here? What have I done wrong? First numbers, character, organization code, any is nothing. Right. Okay. I've done all those. That's mutate. That's interesting. Can anyone spot what I've done wrong? Live mistake making happening here. So what it's saying, I think, is just that there's lots of organization codes that don't have numbers in them. So again, it's a warning. It has made the table. So sometimes you get a warning and you panic, as I did just then, because I'm trying to share a screen and show you, but it's not an error. It's just saying, by the way, we didn't find a number in a bunch of these. So it's letting you know that, should that be right? And yes, we know it is right. So what's it called? Data org code numbers, this one. So there, we've got all these organization codes, and you can see the number, if you're going to use the digits in it as numbers, are all going to be over 50. Everyone happy with that? Did that go okay for everybody? Anyone want me to go over that one again? Oh, cool. Bit of these then. And move on. So sometimes we want to shorten strings, and we can do this by words or characters. So here we've got a great big long string, a long sentence that I want to shorten as it is far too long, he says. It's also gone over this line, so it would be too long anyway. So let's create this object called example, and it'll go into our environment pane as one of the things, one of the objects that we've created. And you'll see here that it just gives us the entire text here to show us what that thing is. This function substring, substr, is how we're going to do this. So with substring, when I hover over there, it gave me a little hint in this yellow box of substring. It's saying, where are you looking for this substring? Which character are you starting from and which character are you stopping from? So you can imagine if you had a column where you know that it's phone numbers. All phone numbers are 11 digits long. Is that right? 11? I think it's 11 digits long. And as long as there's no spaces, it would be 11 characters, right? If you wanted to take the last 3 characters of every phone number, then you would know to start at character 9 and stop at character 11. So you would say, give me substring of the telephone column. The start would be 9 and the end would be 11. So we can be verbose about which one is the start and the stop. You don't necessarily need to write start equals, because the substring function will assume that the second argument you pass to it will be the start and the third will be the stop. So let's bring back what we've said here. So pull out the first to the 15th characters of the example string, which has brought us this bit. This is an exam. Okay, so apparently this is 15 characters long. So that's an easy way of getting a substring where we know for definite where the start and the stop of that substring is going to be. We can do it with Word, which is not something I knew about until I started doing this course. So Word is another function, I think, from Stringer. Yeah, string R package again, which is really useful. Again, we pass it, where are we looking for this thing? The X, we're looking at example, which is this item we made up here. We want to start at word 1 and end at character 4. Uses end and not stop. So again, if you hadn't put end equals in, it would just assume that the third argument is what we were meaning as the end of it. And the separation is fixed as a space. So let's see what that brings back. There we go. So now we've got the first 4 words separated by a space. And it's given us, this is an example, which is the first 4 words of this string. So this is useful for, if we know exactly how many words we want to pull out. And this is if we want to know exactly how many characters from the start or the end, or from in the middle, that we want to pull out from the strings that we already have. So this is useful for really long hospital names. So a lot of you will be NHS people, and working with hospital names and foundation trusts is a pain in the bottom, not least because everybody spells them wrong. So here's a fake hospital name, the Boggins University Hospital NHS Trust, with some errant capitals in there as well. This isn't actually one of the longest I've seen. There are longer ones than this, aren't there? So if we're going to be working with hospital data, we don't want every plot we make, every table we make to have the entire full name in it. Usually we want to shorten that down to something more workable. So what we're going to do is we're going to use a library called TM that is a text mining library. So you probably won't already have it. If you run this line on 1128, you'll get an error that you don't have it. So let's install it. So I just run install, and then it'll tell me install the packages. Yes, in capital letters TM. Go and get TM. It's a big-ish package, TM. So it'll take a little minute to install all of its dependencies. Let me know if you have problems installing that one. Give it a moment. Here we go. And now that we've installed it, it exists in our list of packages in the packages pane. But if I go down to it, you can convince yourself that it's not actually loaded. We haven't loaded up here. TM. So TM exists here, but it's not ticked. So if you want to load it, you can tick this box and it'll run library TM for you, or you can just run library TM. Again, another masking. So if we're going to use an annotate function, and we were expecting ggplot2's animate function, we're not going to get ggplot2's annotate function. We're now going to get TM's annotate function. Don't think we're going to use annotate anyway at the minute, so we don't need to worry. So let's use the remove words function, which is this camel case? I think this is camel case. There's one called Pascal case. I always forget which one starts with a capital as well. But you see, there's not, I would usually have this as lowercase and an underscore between the words, but this is a different type of syntax. That's absolutely fine. We're going to remove words from the long hospital name, which is this item we have created. And we're going to remove the words university, NHS, and trust. So let's now see what short hospital name is. If you want to see what an object is, you can just type it into the console. You can run it here. So we've still got some issues with this hospital name. Is this big enough down here? Are you able to see my screen okay down here? Give me a quick thumbs up. I feel like the console is sometimes harder to read right down in the corner. Yeah, okay, cool. So now we've got some spaces. We've got 2 spaces between Boggins and hospital. We've got big space at the end. We've got capitals in the middle. It's a bit ugly. So what we need to do is squish out the spaces. Okay, so we've got a lovely function called string squish. And we'll apply that to the short hospital name and see what it does. So let's run it again. So what it's done is it's got rid of the extraneous white space. Okay, so we had double white spaces in the middle and I think 2 at the end as well. It's got rid of those, any leading or trailing white space, and then there's white space gaps in the middle are going to give me 1 space, which is what we want. So string squish is a nice little one. And it all works within a data frame. So I'm going to ask you to apply it to a data frame now. So we still have an annoying rogue capital P in our hospital name. Have a look at whether, you don't have to use Google, you can figure out different ways of finding out functions. To find a string function to fix it, we don't want the capitals in the middle. So have a go and see if you can find a way to programmatically remove the capital names. You don't want to be going into your data frame and manually doing anything. We want to apply this to the whole data frame. So have a go at that. I'll give you a couple of minutes. It shouldn't take too long for this one, but shout up as ever if you're struggling. So has anyone found a way of doing this? Is everyone exhausted and just waiting for the answers? That's legit too, I guess. Oh, Mark and Lauren, well done. Do you want to show us how you did it? Feeling brave, either of you, or Ben, who's also managed.
Yeah, I can do.
I'll go on for Mark. That's great. What did you find and how did you find it?
I had a feeling it was something to do with title case. So yeah, just Googled convert to title case, and it gave this string to title function from Stringer.
Cool. And is that what we can see in your console that's run below? If you can run it,
yes.
show us. Yeah. Okay, so that's cool. That's that looks like that's worked as well. Lauren, did you have the same approach?
Yeah, but I just looked for the Stringer cheat sheet and then was like, it must be in there somewhere.
And so that was the same function that you used as well?
Yeah, same function.
Cool. Well done. There are about 1 million different ways of doing this, but well done for everybody that found one of them. So the way that Simon does it is using a string to sentence. So string to title and string to sentence are quite similar, I think. With this one though, oh, that hasn't worked for him. That's interesting. I'll just check. This is his. I think you guys have done better than he has here. Yeah, string to sentence for short hospital name has not worked. So well done. I'll have to tell him that. I'll put a note on to not worked. This is great learning in action. It's really embarrassing, but it's really good. So it was string to title you guys used, yeah?
Yeah.
Cool. Nice. Love it. Okay. So, right, we mentioned factors earlier on. Factors are a data type that converts a character into an ordinal data type. Does everybody know what I mean by ordinal? Ordinal is essentially categorical data. So it's not numeric, it's not characters. What it is, it's separate sets, if you like, of things that have a label, but they are not something that you can do a summary of beyond just counting them up, essentially. So things that would be, oh, somebody shout out some good examples of ordinal characteristics or factors that you work with. Anything?
And I like test names in the lab.
Yeah.
Sodium, potassium, urea.
Yeah, nice. Yeah, that kind of thing. So let's apply our AE dataset to data so that we've got it nice and clean. So data, again, is back to how it was at the very beginning. Here we made this, we used our case when, remember, to evaluate each of these different elements before the tilde. And when that evaluation comes back as true, what gets put into the new mutated column is the thing after the tilde. And then we had a default, a dot default, remember, to put in to the rows where none of those are true. So we'll do this again to make our attendance grouping. So let's create something called data factor. Oh, excuse me, it's data. We're going to filter for a particular date here, the 1st of April 2016, and type is 1. We're going to arrange by the new variable that we just created, and let's have a look at it. So our attendance grouping starts like this, 10,000 to 14,999, and then it gets smaller, which is a bit odd. And then it becomes even smaller still. So it's definitely in a sort of descending thing here. Let's do a super quick plot of it. So we're going to use ggplot, which hopefully everyone's is touched on before. Have you touched on ggplot before? It's part of our introductory course. Has anyone never used ggplot before? Please put your hand up or something if you've never used it before. I'm not going to ask you to speak, just seeing if there's anyone in the room that hasn't used it. Cool, good. That means you don't have to do too much explaining about it, so that's fine. So let's make a ggplot where the aesthetic we're going to give it is that X is on the X-axis we have the attendance grouping, and we're not going to pass it a Y because we're going to do a bar plot. So bar plots by default are a count of the thing. So let's run that, and it'll come up in our plots pane here. So we've got a nice little bar plot. Now you can see along it's quite, let me make it bigger. It's quite squidged in. That's not the problem we're thinking about right now. But look at the order of these categories along here. They don't really make sense. They're not how we would want to see them. We would potentially, we'd be thinking about, let's order them from the highest bar to the lowest bar, or the other way around. But what makes more sense logically is to order them in terms of the numeric contents of these. So we would want the smallest one first, the less than 5,000 to be over here, and then the 5,000 to 9,999, etc., etc. So at the moment, our data fact attendance grouping, what is the, where's the data fact thing? Data fact. Attendance grouping is a character vector. We can see that here. And I could have run class here. So let's say class of data underscore factor $sign to tell it which column I'm talking about. The last one, attendance grouping. What class is that? It's characters. That's another way to find out. And it gives us the examples of the labels that exist in that column. So we want to change that to a factor, and we can make it ordinal as we want it to. So the way we can do this is when we're mutating that new column, the attendance grouping column, we can wrap it all in a factor argument. So the factor, based on we have to give it, again, the name of the thing that we're creating as a factor, and we give it this levels argument, and then we combine the levels in the order we want them to exist. So levels is a combination of, and then we have each of the different levels that's going to exist in our factor. So let's see what that does to the attendance grouping. So now the attendance grouping is a factor with 6 different levels, and R knows now that we want the levels to exist in that order. So now if we rerun the same plot again, we can see along the x-axis, these make more sense. They start from less than 5,000 and then they go up to 25,000 and over. So it's doing that because we've specified that this thing is a factor. It's not arranging them by alphabetical order, which is what it was doing before based on the characters. Even when it has numbers, it's going to arrange it based on characters because it was a character string. So this makes more sense to us, doesn't it? So that's a nice way of doing it, is to make sure that you're specifying when you create something that you want to be a factor, that it is a factor, and you can give it the levels that you want. A lot of people I see come to doing plotting and their columns are in a wrong order, and then they try to change it within the plotting itself. That's fine, you can do that, but if your data naturally has a better way of existing, and so the data should be, this column should be a factor, it should be treated as a factor in everything you're doing, makes sense to do it once at the start of your script where you are creating this new column, rather than have it as a character for all other purposes than plotting, right? Because you don't want to have to repeat yourself in your plot coding to say, oh yes, but treat this one as if it's this order, and then you specify the column names again and again and again. Does that make sense to everyone? Has anyone had to do that before and gone, oh, I don't want to have to do this again? It's something I commonly see anyway, that people try to change the order of their factors laterally in their work rather than early on. So we have created a factor that's got sensibly ordered levels, which wouldn't have happened otherwise. So let's make this a bit smaller. So we can look at our data frame again. We can sort it by that factor too. It can be really useful to show groupings of providers by systems, for etc. We can also reorder factors based on a different variable. So you could have reordered it based on the actual values of these counts if you wanted to, or a number of attendances or highest performance or something. There are further funky things with factors, but we'll have to skim over them apparently. If anyone has questions later on about factors because they've tripped you up in different ways, then we can talk about those because that might be useful for everybody. If you set your data as factors, R will not let you add in data into that column if it's not one of the already stated factors. So say you wanted to create you wanted to add a row to this data frame that had something that didn't have one of these factor levels. So you had something that was, I don't know, because it's numeric, but you get the meaning. If you've got a factor, new data has to be one of those factor levels. You can't then add it in. You can do it, you can force it in, but it is showing you that you've not set up your data correctly from the beginning. So it's a little warning for you to go back and think, oh, so the factor I created doesn't have all the levels I need to have. If you know when you're creating the factor that new data will come in with different factor levels, you can set your factor up to have levels that don't have instances of them in the data set, so that then incoming data won't throw up the error that it's a factor and you can't add data that doesn't have one of those levels. So you can, it seems silly to do that at the outset when you don't have instances of that factor level, but it'll help you later on. So that's just one of the ways of working that might make it a little bit easier. We usually go to 10:30 before we take a break. Is anyone desperate for a break now? Anyone want to put their hand up and say they're desperate for a break now? Or we can carry on until 10:30. It's up to you. We're going at good speed, by the way. We got further yesterday than we usually get in the first day. So we can have slightly longer breaks today or slightly longer conversations. No one's putting their hand up, so let's carry on. Right, dynamic text. Quick note on combining text and variables is useful for writing commentary or dynamic labels on plots. You might not know what I mean by that, but it'll become clear. So we want to create a sentence that says the maximum number of attendances was a number and whatever. We wanted to pull in what the actual number of attendances was. We can create a join. We can join a string together with the paste 0 command. We saw this yesterday, this paste 0. You can use paste as a command without the 0, and what that will do is the things that you paste together will by default be separated by a space. If you don't want that space there, you just use the paste 0 command. My brain always says paste-o, but it's not an O, it's a 0. So let's create this. So we're going to paste together this string, the maximum of attendances was, with a space after it, because then we're going to have a number. So the next argument is the next thing we want to paste together. And we're going to just ask it to find us what is the maximum of the data $attendances. So let's see what this does. the maximum number of attendances was 32,209. So we don't have to know what this number is. We don't have to go and find it and then copy paste it into our text. We can just get R to go and get it for us on the fly as we're needing it. So you can make longer strings and switch between text and non-text with commas. So you can, as we've got here, the maximum number of attendances was this, and the lowest was this. So you can see how we can start to pull together different elements of text and plonk in the little bit of script, R script, that will pull out the number correctly from the dataset for you. And again, this is great when you're writing reports and whatnot, because you don't want to have to be, especially if you're writing a report on an analysis and somebody goes back and changes something. And so all those little numbers that you pulled out into the text are going to change. If you are using this kind of approach, and we do a lot of this in the quarter report training, then you never need to know what those numbers are, and they'll always be correct based on the code, provided your code is correct. And so there's none of that going back to the Word document you wrote and having to check that everywhere you mentioned the maximum attendances, you've changed that number to the correct one now that something's changed in the background. All of that work, all of that to and fro can introduce human error. You might miss one of the things you need to change. You might type in the wrong number. All of that is just thrown out of the window if we're using code to create these text elements instead. So, not Chris. Simon uses the library glue rather than using the paste function, which is fine if you want it. I think I have it. Yeah, so I've got the library glue already. So I ran library glue and it didn't give me a, you haven't got it, warning. So let's create the object max attend and min attend so that we don't have to, when we're piecing these together, write out this whole thing. We're just going to refer to max attend, which will always be the maximum of the attendances and the minimum attendances. And we'll use the glue function from the glue package. Just a note here, if you didn't run library glue, you had it in your list of packages, but you hadn't attached it, as it were. You can still use the functions within it, but what you have to say is it comes from the glue package, double colon, and it's the glue function. So this double colon, you've probably used this all before, but the package that exists in our library, we can use the functions in there without having to load the library necessarily by using this syntax. But because we have loaded it, we don't need to here. So let's glue together this bit, and anything in curly brackets, it's going to treat as not text anymore. It's going to go and find the object with that name and plop it in where we've asked it to. So here, this looks a little bit easier to read than doing it this way. So you might find that this gluing mechanism works a bit better for you. It's a little bit clearer, and you can make sure that these are what you want them to be. And these can obviously be as complicated as you like. It doesn't have to be a max or a min. It can be, a massive output from a huge function. It can be anything. But you can call it into your text if you need to, very, very simply. Any questions on that? Everyone with me so far? Cool. Okay. Going to move on to SPC charts. Quick hands up, who's ever heard of SPC charts and or used them? One, just Emma. Oh no, and Lauren, good. SPC charts are or used to be a very common thing. Anytime we've, oh, and other people, great, cool. Anytime we've got a process that runs repetitively, there will be variation in how that process runs. Okay, so let's imagine you're making forks in a factory, right? And you're monitoring how often the forks come out wonky from your machines. There will be variation around that because there's variation in everything in life. But we want to know whether the amount of variation that's happening is out with normal. Oh, there's a hand up there. Sorry. Do you want to jump in? No, maybe not. Oh, you're on mute if you're speaking. Sorry. Not to worry if that was an accidental hand. So yeah, with SPC charts, what we're doing is we're statistically determining what is normal variation levels, what's normal noise in the system, and what's potentially a sign that something is going wrong. And we want to do that empirically. We don't want to do that guessing by eye. So statistical process control graphs are something that can allow us to look at a process, the variation that is normal for it, and anytime when the variation is in whatever it is we're measuring is more than we would expect, and that would lead us to then investigate what might have gone wrong or what might have changed. So our NHS-R community has produced a volunteer-led package called NHS-R Plot the Dots, which you can get on CRAN. So the NHS-R Plot the Dots, big long name here. You should be able to, yeah, so I haven't installed it today. So let's go and get it. Install the packages, NHS-R Plot. Oh, we need to do it in these, don't we? NHS-R Plot the Dots. This is a package that's been downloaded now tens of thousands of times. People are using it all over the place. So there was a real need for it. As you get happier with R and more comfortable trying things out, you can create your own packages too. You can also contribute to packages that we've got, the community's got. We'll talk about that more later potentially. But Plot the Dots was created by members of the community, for members of the community. But as I say, it's now been used all over the place, not just in the NHS, all over the place in policing, in health and social care, in all sorts of different places, because it's just a really useful set of little functions. So what we're going to do with it, we're going to create a data set called Data SPC, which is just going to be the RVR organization and type is 1 from the data. And we're going to use the PTD SPC function. So let's see, again, we should F1 it within the Plot the Dots package. It'll take us to this website to look at the help. Oh, no. Come on, yes, you can. My internet's having a bit of a moment. Right, refuse to connect. Anyway, the PTD patient, I can't remember what the PTD stands for, but this function, we have to give it a value field, and we're going to give it the column attendances, and the date field, which we already know is that period column. So let's see what happens. I haven't loaded the library, that's fine. Sorry. At least once a day. So if we F1 on that now, yeah, okay. So now we've got, because I hadn't loaded the library, when I tried to look for help on this function, it went no. So I've loaded the library now, and this is what it gives us in the help function for the Plot the Dots package. PTD SPD, what does it actually stand for? Oh, Plot the Dots PTD, of course it does. Okay, so it's the base function anyway from this package, and we can give it optionally all of these elements. So when it's telling you what arguments the function requires, if it's got an answer, like this one has got null, then that's the default. You don't necessarily, if you agree with that default for your use case, you don't have to set those arguments. You don't have to give an answer for every single argument. So we're just giving the value field and the date field, which is what the minimum that they need. And if we run that, what we get is a chart like this. So we're plotting the time series over the whole of the data set, and we've got these organized correctly in date order, because remember our period column is already known to R to be a date. All of these dots are grey, and the grey means common cause. So that's just a bit of terminology from statistical process control, in that it's not worried that any of this wiggle, this natural wiggle that's happening in this line is to worry about. It's just part of the natural noise of whatever system this is, and this is number of attendances. So there's no reason to worry that we had that this, for example, was over high, or this was too low, or not too low, you know what I mean? It doesn't make sense for these data. But we have these control lines here. Had any of these dots been out of there, or had there been a run of dots going upwards, trending upwards, it would have let us know that by highlighting them in different colors. So an SPC chart being produced really quickly like this is dead nice, because there's a lot of time that we want to see whether the wiggle in a time series is of an alarming amount. This would have been used loads during COVID, remember, when we were all looking at COVID diagnoses numbers and death numbers as well at some points, because there was a tendency for people to react a lot when the numbers went up, and then feel potentially overly relieved when the numbers went down a bit. But it was all oftentimes within the natural wiggle of a natural system. So SPC charts would have been really useful for some people to use to avoid those assumptions. Okay, so over to you. Add in a target of 17,500 somewhere into this element here. We actually want to show improvement as a reduction. Okay, so you might need to go into the help function for the plot the dots SPC function and see if you can figure it out. Renee.
Yes, please. I just wanted to find out, sorry, I've not read the documentation, but the dotted lines that fall outside, is it like the 2 standard deviation or the 3 SD?
Let's have a look. Where we are, it's in the help, wasn't it? So let's have a look. So what we get out are, it is standard for SPC. I can't remember, to be honest with you, if it's somebody who's better. I don't use SPC charts in usual life. It is something along those lines that it's within 2 or 3 standard deviations. There is a statistical threshold there that we've got outside or inside the common cause variation, or the whatever they call it, exceptional cause variation or something. So I can't remember, I'm afraid. You'll be able to look it up / Google it. Not a good answer. Apologies. So have a go at changing the target that you want the attendances to be at, and see what that does to your plot. And what about if we actually want to show improvement as a reduction? Have a look through the help files for the PTD SPC and see if you can make those changes to the plot, and then we'll come back in 3 or 4 minutes to see what we've managed there. Okay. I'll go and find out the thing about where the control lines are as well, Renee, just now. And I'll pop it in the chat when I find it. Any thumbs ups from anyone who's managed to complete this little task? Well done, Sabrina. And Mark and Lauren. Oh, and Danielle. Oh, hi, Danielle. Yeah. Oh, and Jenna. Cool. Brilliant. So that's quite a few that have managed. So let's pull everybody back in. Anyone want to share their screen and talk us through how they managed this? If not, don't worry. Okay, I'll share my screen. So I've written in here how I would do this. So to answer this one, you needed to know, we needed to find out whether these things could be done within the PTD SPC function, which they can be. So we'd already passed it, which counts are we looking at, the value field, which time series column are we giving it, period. Then we can give it an argument called target. And you'll have seen this in the help at the top. One of these variables, again, says target. And we're going to give it the 17,500 that we said above. And we can give it improvement direction. And so generally speaking, it would be increase by default, as you see here. So in most cases, increase is a good thing. In this one, decrease is a good thing. So we can pass it decrease. And again, just to note, you see here in the help file, they've used double speech marks, whereas in this code, I've used single speech marks. Doesn't matter as long as they match at the beginning end of the thing you're quoting around. So let's look at what that does to our thing. Okay, so our target's bizarrely way above where our attendances are. So it's not a very realistic situation. But there we are. I popped in the chat that by default, I think the grey dotted lines that you get on SPC charts are by standard, they're 3 standard deviations away from the mean. So that is quite a large distance from average, if you like. So anything out with that would be quite exceptional. You'd expect it to be uncommon. I think you can specify in this package exactly how much variation you want those lines to be at, but it's useful to keep it as standard because that's the way that you understand, comparative to other processes that you've got going, how exceptional some values are. Right then, everyone happy? Lauren?
2 questions. So one, what is that little P in a circle? Is that like passing or something like that?
I think it is. Yeah, so she's talking about this little thing up here. It's stylistically added basically by this package to show you what this line is. So I think they're telling us that generally speaking, our things are lower or higher because we've got directions. So we want it to be below. So the P probably means passing, like you say. I don't know, to be honest. You'd have to dig into the help files again to figure out what that means. Let's put a target of way lower and see what it does. So let's put a target of what's lower. Let's put 9,000 and see if the P changes. Failing, yes. So P and F, yes, so yes, it's passing or failing, I think. So if the target was 9,000 and our data are all well above it, in the default scenario, that would be a good thing. But in this scenario, where we've said an improvement means a decrease, then it's bad. Okay, so failing at all points, we're failing because we're above that target of 9,000. Okay, that was a good question, thanks. And it changes the color of this to make it nice as well. So that's a little handy thing they've added to the package to make it even more readable.
So the other question
oh yes, sorry, go on.
Sorry, was so obviously it's got the 3 SD lines. Do you know if it's customizable to put additional threshold lines on there?
I think it is. Yes, I think it is. Certainly other plotting packages for SPC can do that. So you would have potentially a 1 SD control limit as well as a 3 SD control limit, depending on how you and your organization work and want to understand the variation. I think you can, yeah. If you can't, what would be a really nice thing would be to add an issue to the repository for the package. And then you have contributed to the package by saying, it would be good if we had this, please. Then either yourself could figure out how to do that or somebody who works with the package could figure out how to do that. So that would be awesome. Is it something that you do a lot, doing SPC charts?
Yeah, but not really doing R. So obviously in the labs we're running like thousands and thousands of tests on loads of samples every day, and our routine analyzers have statistical process charts for checking that our analyses are in control. So yeah, they're a really standardized part of lab practice.
And they do the 3SD control limits as standard as well, or do they have multiple ones?
So it's a bit more complicated than that. There's something called the Westgard rules that get used, which look at kind of number of points at different places, but generally you have kind of 2SD and 3SD limits, and there's a whole load of rules about how many you have in a row above a certain point, etc., etc.
Yeah. Great. Well, this might be something that becomes quite useful. I've no idea what Levy-Jenny's chart is, Renee. Do you want to tell us what Levy-Jenny's chart is?
I mean, it's essentially a statistical process chart. Sorry, Karen.
Oh, yeah, no, it's just speaking to what Lauren is talking about. The internal quality control in the lab uses the Levy-Jenny's chart and then the three SDs for interpretation. So I did some stuff around that before. Yeah.
So hopefully this is speaking to you and is useful. So that you can run your own SPC charts and you can modify it in whatever way that makes sense to you. Obviously, for lab work, it is centrally dictated, isn't it? Essentially, what variation from normal should be acted upon. You don't want to be changing the goalposts, as it were, arbitrarily. So I think that's why we have 3SD as standard on these plots. But if there's something more useful the package could deliver for your particular use case, then that is something that you can feed back to the package maintainers, and they might be able to implement that for you. Awesome. Any other questions? Everybody managing to get a plot anyway that you're happy with? Silence is a good thing, I think. Well done, Ian and Sabrina. Cool. Good. Right then. We're nearly at 10:30. I suspect it's a good time now to go and have a little bit of a break. Shall we come back at 10:45? That's a longish break, but I think we've done well this morning. So let's come back at 10:45 and we'll work through the last bits of this script. I'll be around. I'll have my camera off, but if you've got questions in the meantime during the break, then do just come back off mute and stuff and ask me. All right, great guys. See you at 10:45. Hello all, welcome back. Hope you've all managed to have a bit of a break, grab another cup of tea. There were a couple of comments in the chat during that that I am investigating on Lauren's behalf to look at what Simon was referencing when he was talking about creating factors on the fly. There's lots of different things he could have been talking about there, so I want to make sure that we capture what was actually in his mind, given he wrote this this script. So I'll come back and put these in the chat at a later point. You should always have access to this chat now, I think, even after this session ends. But if he comes back during this session, I'll just read it out to you and let you know what it is. All right, then. Where were we? We were roughly at line 1293. Well done us. What we're going to do is continue with the SPC chart process a little now to show you how we can create a more realistic workflow. So first we want to create a chart for each type of attendance. I should imagine for our lab colleagues in the room that it's rare that you want to run one SPC chart. You're going to want to run them for every process you have that needs to be looked at. So let's see how we can do that, provided they're all within the same data set. So let's just choose one organization code to look at so we don't have too much data. And then let's make use of this facet field argument within the PTD SPC function. And we're going to do it on type. So let's remind ourselves what type was. Our SPC data is here. Type is this column here, which is 1, 2, and other. It's only got those levels. So let's facet the SPC chart by type. Make this a lot bigger because it'll be very tiny. So we've got three relatively silly looking charts here. We've got an SPC chart that's way above the 0 element on the y-axis. Our dates are all a bit squished. We've got one here that was obviously something that was recorded at much lower attendances. And then we've got one that's got lots of interesting colored dots going on over here. And it says, hi, problem. So let's see. It looks a bit clumpy. We need to tweak a few things to make this a pretty GD plot. So first of all, let's turn our plot into an object so then we can refer back to it, add things onto it easily. So we'll call it plot SPC. So we'll just run this to make sure that we create that, and it'll be in our environment once we've created it. All right, when you run it down here, SPC, and press enter, what that'll do is it'll show me that plot again. It's exactly the same plot we just created. See it in my list of things. Why can I see it in my list of things? Well, never mind. It has created it because we can rerun it and recreate it from the just giving the console plot underscore SPC. So let's feed that object into the create GG plot function, which comes from the same package. So we take that plot, we run plot the dots create underscore GG plot. And again, how do we find out which arguments need to pass to this? Let's look at the help file. We can give it lots of different things. So there's lots of variety we can use here, but we're going to use the fixed y-axis multiple is false. So you can imagine when we were looking at that plot, we don't want these all to be on the same y-axis because it means that we've got wildly different scales here we're working with. We want them all to have a nice readable SPC plot somewhere in the middle of the chart. So we'll do that there. We want to format the x-axis date format. So this should be familiar to some degree. When we're working with dates, we have shorthand for the elements that go into a date string. And they are all prefixed with a percent sign. So percent lowercase b is the month. And I think it's the month as a shortened form. So like a 3-letter form of the month name. And lowercase y is a 2-number date year, even. I'm so tripped on my words today, sorry. So it would be, it would be 25 for this year, whereas a capital Y within a date would be the 4-digit year. So let's do that and see how it changes our plot. Okay, so because we've freed up the x-axis a little bit, we've got a different y-axis. We've got the y-axis in different scales for each of these plots to make sure that we're using the space we've got as much as we need to actually see these plots nicely. And we can see, although it's still a little bit jumbled on the x-axis here, that we've got these, for example, April 16, so APR space 16, because we've specified we want the shortened form of the month name, then a space, then the 2-year form of the date. of the year. 2-character form of the year. Sorry. And now look, because we've got some interesting stuff happening within our other group of type, we've got some blue dots now, which are special cause improvements, and red dots, which are special cause concerns. So improvement, as you can imagine, is the dots are going in the right direction. We've specified that a decrease is a good thing with our plot. So it's telling us that here, and we've got some that are out with the lines up here as well. So all of these allocations to different categories are based on what statistical rules are programmed within the SPC itself. So we don't have to figure out which dots are which, and which runs of dots in a particular direction are worrying or not. Is going to tell us that with one chart. So that's nice. So I want you to play around a bit now with SPC charts again. So this is what's called a faceted plot. We've got 3 different mini plots within this plotting pane. If you like, that's faceting. We've got 3 facets here. So create a faceted plot for type 1 attendances for these 3 different trusts, these 3 different organisation codes. And then change the point size to look a bit nicer, whatever nicer means to you, doesn't really matter. Just change something about it to convince yourself that you can. And then change the x-axis label to date rather than period. So the actual label here, so it says period here. We don't want it to say period, we want it to say date. How could you do that? And then make any other changes that you feel would be useful to help this chart really pop and give the understanding of the data to the person looking at it. So I'll give you a few minutes to do that. When we come back, I'd really like it if a couple of people could show us what their plot looks like, because no doubt people will do things differently. But let's have a look at them. And if anyone has problems, as ever, just shout, put your hand up, whatnot. It's 10:53 now, so I'll give you 5 minutes to do this. All right? Give me a shout if you need any help. Off you go. Sorry, guys, that took a little longer than I was intending because I had a phone call. Right, has anybody managed to do that last element that we had with the SPC chart? Can anyone show me what chart they've produced? And see if they're, and we can talk through whether you're happy with it or not, what you might want to change later on. Is anyone feeling brave? Come on. Nobody? Oh, no, Lauren says yes. Yes, go for it, Lauren. Thank you. You're muted as well, just in case you didn't know.
Sorry, yes.
That's lovely,
this is my
it?
final chart.
That's beautiful, isn't it? That's lovely. So we've got 3 charts on different scales. That makes a lot of sense. So we can see each of these time series clearly now. We've got some nice smaller dots, which does make it a lot clearer. They're not too small that you can't see the colors though, right? Which is really, really helpful. What else have you changed here?
I just got as far as putting a title, so type 1 attendances at the top, but that was about as far as I got.
Really, really nice. No, I think that's great. Any comments on this from anybody else? I think I wouldn't have anything to improve upon. I think this looks really, really nice. Anything you would want to change about this, Lauren?
I mean, I would like the statistical limit lines to kind of line up and the mean lines and have the axes shifted, but I don't know if there's a way to do that.
Not easily, I would have suspected. I think having those lines line up despite the numbers being different is going to be tricky.
Yeah.
It would be nice though, wouldn't it? Quite a lot of the time when we're putting out reports that have faceted plots in them, it doesn't usually make sense to have more than 2 facets anyway, just because especially with these kind of time series, there's a lot of data in there. And so, you know, it's usually better to give them each space. So it's not necessarily something that would come up often. So I wouldn't suggest that the package maintainers would be getting that question a lot, if you like. But yeah, it would be nice for us perfectionists to have everything lined up nicely. But this looks really, really good. Well done. I think that's fantastic. Thanks for sharing. I'll pop here. I'll talk through what code that Simon delivered to do this. We'll talk through this quickly. So Simon again created a plot that is the SPC data with these 3 organization codes and the type 1 rows. And then what he's done here, again, value field is attendances, date field is period, the improvement direction is still decrease, and the facet field is now organization code. So rather than faceting based on type as we did here, we're now going to facet based on organization code. If we did this without specifying only a few of these, we'd get loads of squished in charts, wouldn't we? Because we've got loads of different organization codes. So ensuring that we've only got a sensible number will hopefully make sure that this looks nice. So let's run this as it is currently. And we've got 3 charts there. Again, they're all using the same y-axis, which might be fine. The dates are all a bit squished. I mean, I could make this full size and it would be a little less squished, but still, there are some things we could improve. And this title, as Lauren's changed, probably isn't very sensible. We know it's an SPC chart. We can see it is. It's useful to have the title saying it's of attendances, but we've got date fields here so we can tell when it's starting. So I wouldn't necessarily have that in the title. So what he's done here is use the PTD create GD plot function, and he's passed it the fixed y-axis multiple is false again, which we did before. Again, we've changed the format of the date field as it will appear along the x-axis. He's done a change in how frequently we want to see the ticks on the x-axis to make them a little bit more spread out so we can read them more easily. So he's done this using the x-axis breaks and done it as 2 months. So we pass this as string based on usual way of working with the words there. So it would be a number of months or days or years or whatever, and it can handle all that. So he said, I only want to see the date written on the x-axis every 2 months. He's made the little points a bit smaller. He said point size is 2. The main title is now something he's just created as Simon's SPC plot. And the x-axis label is how we can change this name down here from the automatic one that it's picked up from our data, which was period, to date. And he's changed the icon position as well, to the top left instead of the top right. So the icons are these ones, I think. And he's changed the icon size. So let's see what this does. Oh, that's nice, isn't it? So let's make this bigger so we can all see. And hopefully you can see easily the effects of those changes have had. So these icons are now a bit bigger, but easier to read. And the dots are a little bit smaller comparatively, and that's fine because we've got lots of them. And the dates are easier to read and they're not overlapping each other quite so much. So all these little changes are things that you want to do to make sure that nobody's having to struggle to read your plots and the story of your plots is coming out loud and clear, because that's the whole point of plots, right? Is to take boring, dry data and make it into something that feels obvious as to what it's trying to tell you. Right, brilliant. We're going to move on from SPC now. We're going to start talking about functions. So can I get a quick hands up in the room as to who has written their own functions in R before? Got a few people. Okay, cool. So a little handful of people have had a go at this before. Great, well done. I'm really happy that some people haven't. So a lot of the power of coding in languages like R is that you can build your own functions, and the extensibility of that is therefore infinite. So if there isn't a button to do what you want, and speaking to things like, you know, point and click programming like Excel and things like that, if they haven't provided you with a button to do a job that you need to be done, that job can't be done. Whereas if we are coding, we can create buttons that do whatever we want them to, and this is what we do with functioning. So say we want to do the same set of actions multiple times. We could copy and paste our code, but that is going to be a waste of writing, waste of time to do. And if you make a change to one of those elements, you're going to have to make sure you remember to copy and paste that change again and again and again. And it's not one of the approaches that we want to use if we're working towards reproducible analytical pipelines, or the RAP principles, which are what we should all be trying to adhere to and use as much as possible. We've got a saying in data science that acronyms itself down to DRY, D-R-Y, which is do not repeat yourself. So if you find that you've got lots of code where you're copying and pasting the same thing lots of times, that's an indication that there's something more elegant you could do here, and a safer way of coding. It also means if we update something, if we're writing functions, then we have to update it all in the duplicate instances of that code, and that can introduce human error, so we don't want to avoid that. So let's do functions instead, so we can repeat the steps that we want to go through exactly the right way every time. So let's start off with a simple example. We've got 3 objects we're going to create called X, Y, and Z, and they each have a different value, 5, 10, and 15. Just see that we can see them down here in our objects, 5, 10, and 15. We want to triple each of our variables. We could just write out X times 3, put it in here maybe, X times 3. Oops. Bit of an issue, X times 3. Right. My project's gone to sleep. I haven't done anything with it for a while. Give it a moment. My cloud is running relatively slowly today. I don't know if any of you are struggling as well, but we're getting there. Anytime you like. So if we wanted to triple each of these X, Y, and Z objects, we could just write out the X times 3 and then press enter down here and we'd have a number, etc. But that would be repeating ourselves, and do not repeat yourself. In longhand, we could do this. We could create a new object called X mult or X multiplied or something, and give it the value of X times 3. That would work for that. But imagine we had 100 different objects and we wanted to multiply them all by the same thing. That would be super tedious. And if we changed it from 3 as the multiplier, we needed to multiply them all by 10, we'd have to go through and manually change all of those as well. So let's build a function. We start by naming a function. Naming things is hard, okay? With functions, a lot of the tidyverse functions have function names that make it as obvious as possible what that function does. And a function should do one thing well. Okay, so you might, when you start writing functions, make your function do loads of whizzy things all in once. That's a problem often, because when the function falls over, you don't know which element of the function was the problem. So a function should do one thing well and give it a name that speaks to you and tells you exactly what that function does. So our function is going to be called times 3. And the way we set it up is we have the word function, with or without a space after it, and we give it one or more arguments, which are the elements it's going to work with. And then within curly brackets, we tell it what we want to do with those inputs that we're given. So in this case, we want to return input times 3. The return statement is one that we don't always need to have there, but what it does is it's quite verbose in telling us that the things that we're creating within this function, we want them to be available outside it afterwards. Okay, this might come back up in this tutorial a bit later. So let's run this. We're not expecting anything to happen when we run this, apart from the fact that we're creating a function that's called times 3. So when we run this, you can see it repeats what we've said in the console, but it's not actually giving us an answer because we haven't applied the function to anything. So now when we want to perform the action of multiplying by 3, we can just feed it what we want to apply it to. So let's say times 3 with the x value, it should give us the answer, which was that, remember, the value of x was 5, so 5 times 3 is 15. We apply this function to the y value and it gives us 30, and we can give it any input that it makes sense to multiply by 3. Just for funsies, let's do it times 3, and we'll give it the word apple. What will it do then? Anyone want to guess? Will it say apple 3 times? What will it do? Well, we know that multiplying a word doesn't make sense. So let's see what it does in this instance. It's going to give us an error, and it's going to give us this really common and slightly annoying nondescript error message here. So in input times 3, it's saying there's non-numeric argument to a binary operator. So essentially, in common parlance, what it's saying is, I don't know how to multiply a word. That doesn't make sense. Multiplying is not what we do with words. So we would expect an error here, and that's a good thing. A function can only return one object. So if you create multiple functions, you're going to need to be multiple things within your function. You're going to need to be a bit clever about that. You can add more than one variable into a function separated by commas. So if we wanted to do something with 2 different inputs, it's slightly, so we've given them x and y names here, but we didn't need to. And it's a little bit confusing that it has, because we've already got something called x and something called y. But anyway, the x times y function is a new function we're going to create that takes a value for x and a value for y, and we create something called result, which is the multiplication between those 2 things that we give it. We also create something called b, which is just the number 150. And what will be returned is the combination of this string, the answer is, combined with the result number that we get by multiplying x and y, pasted to, and b is, and it will just give us b again. So let's run this. And again, we haven't applied this function yet to anything. We've just said this is a function that could work. Let's now apply it. So we can run just this part, x times y, given x and y. Let's do it down here just so we see. Ooh, not twice, you see. Ah. Oh my goodness, right. Oh, right. X times y with x and y. The answer is 50 and b is 150. So we can create, we've not got a space here, so let's add a space in there just to make sure it's right. So let's rerun this to overwrite what this function is, and we'll do it again with x times y there. So the answer is 50 and b is 150. If we wanted to capture this output, we can do by assigning it a name. So again, here we were deciding that the output of this function is going to be called var. And so we've got the answer here, and if I type var, it will again give us what the value of var is, which is the output of the function. So all functions are set up in the same way. We say function, we give it one or more, or sometimes no arguments actually. We do something with those arguments, or do something within the curly brackets, and we make sure we're getting it to return the thing that we want. You don't have to specify what the thing what is returned within a function. You do not have to specify what it returns with a return function. So yeah, so as I was saying, the return function, we're being verbose there. We're making it clear to you, the coder, what's going to be returned by wrapping it in a return function. You used to have to use it. You don't anymore. Things have moved on a little bit. So it will return the last thing that is created within the function by default. So here on line 1420, we've got x times y no return. Is a horribly named, but verbose name for this function that takes arguments x and y. And the things it does with them is it multiplies them together, and then it prints a pasted string that has the answer is and gives the result. Let's do this. So that function is now in our memory, so we can use it. And let's feed it 5 and 4. Let's see what we get out at the end. So it's not given us result because we haven't asked it to, and that result is not the last thing it did. The last thing it did was create this, which is returned to us as the answer is 20. Does that make sense to everybody? Oh, Renee, you put in the chat error, just general error. Do you want to, was it an error on this bit, or do you want me to go back a bit, or?
No, sorry, I was responding to your initial question when you say you put apples into,
okay,
yeah.
Sorry, I wasn't keeping an eye on the chat. It's a very valid thing to just error in life as well. We do that, so I was just checking. Thanks. Okay, good. Okay, so going back to our curly brackets and the scope for a function. So what happens in a function scope is not in the global environment, you know, these things that we're creating up here, that are data frames and objects. And look, we've got functions now in our environment that we've created. So the function doesn't write anything into the global environment. What gets created in a function stays in a function, essentially. So after the function is finished running, everything else that's in there will just disappear. It won't exist anymore unless we do something about that. So for instance, the variable result that we created here hasn't been created in our environment. It only exists within the scope of the function. It can't affect the outside world, so we're not going to be reading these things into memory until we do something specific to tell it to do that. Okay, so let's do a little extra bit. So we're going to create an object called test, which just has the value monkey. Where's it going? Test is the word monkey. Okay, so here we're going to use our x times y scope is a function that we give x and y. The result is those things multiplied by together. We're then going to again create something called test, which is now the word moo for some reason, and we're going to print a statement. So let's see what happens. So you wouldn't expect the global environment version of test, which has monkey as its value, to change, but let's see if it works. So then we're going to run this, giving it the values 5 and 4. And you can see that in the global environment, test is still monkey, because although we create a test within this function, it hasn't affected the outside world. It's only going to be true while that function is running and within the scope of that function. You can make a function as complicated as you want to, but always bear in mind that a function should ideally do one thing and do it well. Not one element of work, but should create one thing. So here we've got, these get longer and longer, x times y plus 10 date. Okay, so we take the result of multiplying these together and call it result while we're in the function. We create something called day of the month, which is a lubridate function called day, which is similar to the lubridate function we saw earlier, which was called month. We're passing it this. So I don't know if you've all come across this. This is a base R way of getting the date as it currently stands in the system. So if I run sysdate here, so it's system date is what it's short for, without any arguments, it should give me the date of today. Okay. So if you run system date tomorrow, it'll give you tomorrow's date, etc. So we want to pull out of that, what day are you talking about? And day, I think, is the numeric day. So yeah, we're on day 15 of the month. So it's the 15th of the current month. After it's created result and day of the month, we're going to pass it an if-else statement that we saw earlier in day 1. If the day of month is over 15, then take the result and add 10 to it. Otherwise, just give us the result. Everyone got that? Know what they're expecting this function to do? Let's load the function into memory. It'll get added to our massive list of functions that we have now. Okay, he said here, without running the function, please type into the chat the result of the function. What do you think we're going to get back if we run this? And the chat to see your answers. Oh, we've got difference in the answers already. We've got 13s and we've got 30s. Oh, and a 40. Any further guesses? Another 30. 30 is obviously a popular answer. Let's see. Let's find out what happens. 30 was the correct answer, so well done to those who got it. Let's walk this through. So X in this instance was 3 and Y is 10. So result becomes 30. The day of the month is the day of the current date. So that, again, that was 15. So we evaluate this statement. Is the day of the month over 15? It isn't. It is 15. So it's not more than 15. So we're going to return not result plus 10. We're going to return just the result as it currently was, which was 30. Okay. So this bit might have tripped you up. You might have thought this meant if it's 15 or over. If we were doing that, we'd have said more than or equals to 15. But we haven't. We've got, is today's day more than the 15th, later than the 15th? So well done to those who figured that out. Functions get pretty convoluted quickly, this is true, and can be hard to read, which is why it's good practice to write doc strings for the functions. Anyone who's come across Python, doc strings is documentation strings, basically just means text that explains what things are happening in the function. And there's ways of writing that are standardized, but as long as it's clear from the things you've written in and around your function, what it's going to do at each step and what should be returned from it, then you don't have to follow those customs necessarily. So as an example, we've got a new function, x times y plus 10 date. Oh, that's the same function, isn't it? Again, we're redefining this function as x and y. And here he's put in loads of lines starting with the what do you call it? Hash or pound sign, I think, if you're in America, which, as we know, just means comments. So nothing that follows one of these on a line will be evaluated by R. It's just text writing to yourself. So he said out in words, this function multiplies two numbers and adds 10 to the result, blah, blah, blah. So he's going through all of this and adding the actual lay English understanding of what this should be doing, which is really helpful. It does, I mean, not so much with little functions like this, where it's very obvious. As your functions get long, always do this. This syntax here is a way of writing standardized doc strings, as it were. So when we have a hash and then we have an @ sign and there's some keywords here, param is a parameter. The arguments that we're going to use in our function are called parameters. So we have to explain what are the parameters, what kind of thing are we expecting there? Is it going to be a number? Is it going to be a vector? Is it going to be a whole data frame? Is it going to be a map? What is it? Explain what the function should expect. And then the @return tells us what we're expecting to get out of it. And then often we also have examples. So when we write comments in a way similar to this, using something called Roxygen comments, these are what is automatically pulled out from the code in packages to build the help files. So the help files are all written in a particular format because they all have the same elements. The parameters are explained, what gets returned is explained. There are the examples, as we've seen, it always exists down at the bottom if they have them. And it explains all of the things that come out as well. So this is a lot of writing for a little function, but imagine your function is 100 lines long. You're going to need all this information. So writing out exactly what each element of your function does and what you're expecting is really, really useful. So this is an extreme example with multiple examples of how the function is used. At the most basic, you should include a description and a variable description. You want people to not use your function, including yourself, with the wrong data type, so you get out plausible but wrong answers, and you don't want it to fall over an error. This function will fall over if you feed it the wrong data type. More advanced functions can handle error checking and testing. We won't worry about that today, but you can allow your function to take arguments that are wrong, as it were, and then give an informative message and say to the person running the function, oh, you've tried to give me a string there, when actually what you need to give me is a number. So yeah, doc strings and using them to make sure that you understand what's happening in your function, that other people will, and that you will when you come back to it later is really important. So a little task for you now. Tweak the function that we made just above so that instead of times the first two inputs, instead of times the first two inputs and add 10 to the result based on the day and the month, it adds a number that you specify. So you're going to give it another variable. And for bonus points, assign your result to a variable. So do you understand what I'm asking you to do there? Anyone want me to go over that again? A good thing. Okay, cool. Crack on with that then, and give me a thumbs up when you're done. Some people fly through this bit and some people really struggle with this bit. So take your time. If you're struggling, let us help. We can share screen. I'll give you a few minutes to do that. I'll add this to the chat as well so that you can see it easily. Right, come back in 5 minutes or so.
Hi, Claire. Can I just double check something?
Yeah, of course you can.
So are we keeping the day of month logic? So the if else bit?
Say that again?
Are we keeping the sort of compare it to the current date bit?
Yeah, I think so.
Yeah. And when it says for bonus points, assign your result to a variable, as in you want the output to become a new variable in the global environment?
Yes.
Okay, that's going to be a problem. Thank you.
Anyone done? Anyone need a few more minutes? There's a thumbs up if you're done. Or you're just done generally and just want to see the answer. Maybe another minute. Right then, can people give me a thumbs up if you're not hearing a really loud lawnmower in the background? Just so I can be sure that you can hear me okay. Yeah, thanks. Okay, good. It is really loud. Teams does quite good things with muting sound. Anyway, okay, this was a tricky one, right? So if you're new to functions, getting your head around functions can be difficult, but it's worth sticking with because it's the most powerful arrow in your quiver, essentially. Let's have a look at how Simon attacked this problem. Right, so we have our function name, which is ridiculous, but hey, it says what it does what it says on the tin, which is useful. And we're going to give it, we're going to use 3 different inputs now. We're going to give it an X, a Y, and another thing, which we've called add. So then the scope of this function is here, and within it, we create a variable on the fly called result, which is the 2 things multiplied. We again extract the day of the month that we're on by running the day function within system date. Then we run the if-else statement that we had before, but we've slightly modified it. So if the day of the month is more than 15, then we add result to the variable that we passed in called add. If not, then we just keep it the same. We just keep it as the x times y. So this function now does the things that, this was quite difficult in English to understand what he was saying here. So I'll understand if you struggle with that a bit. And assigning it to a new variable means we capture the result into the global environment. So what we're going to do is we're going to apply our function. Now we give it 3 different arguments. And again, we don't have to say, we could, however, say x equals and y equals and all this kind of stuff. We'd be really verbose about that. But generally speaking, we don't need to, as long as we are providing it the arguments in the order it's looking for them. So the first thing is going to be the x, the second is the y, and the third is the add value. If we run this without assigning it to a variable, we get the number 4. If we create a new object called variable that is the result of doing this, then obviously variable will exist in our environment pane with the relevant answer, with the number 4. Everybody with me there? Any questions, any worries about this? Is this feeling okay? Are you following along okay? This is the bit where I start to lose people, I think, with the functions, because sometimes people are, you know, it's another step up. So good, thank you for the thumbs up. That's nice to see. Right, getting there, guys. Sorry, 11:30. We've not got much to go. Okay, we can apply our made-up functions to a whole data frame at a time. So this is where we start to get powerful with this. We want to apply it all over the place. So how do we do that? So we're going to create an object called data fun. For some reason, it's not fun, it's to do with function. Where we take the data frame, we restrict it to these rows that meet these conditions, and we don't want the breaches column. So we'll remove that by saying select not breaches. Okay, let's create a new column, which it is a ridiculous name, Simon, actually. Yes. So we're going to take the thing we just created, that data function, data fun data frame. We're going to do the row wise, remember, which then says we're going to evaluate things row wise, not column wise now. And we're going to make a new column that is called attend times admit maybe plus 10, which is ridiculous. And what that's going to involve is using our function given whatever value is in the attendances column and in the admissions column, and the add remember we needed an add value, it's just going to be 10 all the time. So let's see, let's look at data fun first. Data fun. So without running our function yet, data fun looks like this. So it's a subset essentially of the previous data set. So let's now run this with our function applied to create a new column with a stupid name. So again, because it's row-wise, it's worked here. It's gone across the row and said, okay, the value for this, are the X and the Y, and then we're going to be using 10 as the add all the way along. And it's quite happily made us a new column based on that. So whatever you want to do row-wise, you can create a function to do it for you and then just apply it to your data set. And that is a really nice way of scaling up what you can do with your functions. It is a silly example, Simon, yes, but it shows what potentially can be done. So it can be great for calculating rates per 1,000, per 10,000, whatever you do, if that's something that you do in your usual work. So let's do another quick example. Oh, Lauren.
So when I did my version of the function, I changed the name of it. So my function doesn't actually, the original x times y plus 10 date doesn't have 3 input variables. Yet when I run it, it doesn't give me an error. So is that because I haven't put any error messaging within my function?
Yeah, it's still going to do what it can do. And it's going to ignore arguments that are not needed. Usually it would give you a warning, but not necessarily. So it is around the error handling that is. So it's got an X and it's got a Y. If you hadn't given it an X and a Y, if you'd only given it one thing to work with, then it would have gone, I can't do a multiply when I've got a missing side. But giving it extra arguments hasn't made it fall over. If it was important for your function that it did fall over, you wanted it to fall over if people gave it too many arguments, then you would manage that with the error handling that you can do within the function. So yeah, that's no worries. Yet another over to you. We make you work hard on the second day, don't we? Right, let's create a function to calculate the mean of 3 numbers without using the mean function. So that would be cheating, too easy. See if you can do that, and then create a function that calculates the mean over any set of numbers. Happy with that? Happy-ish? I'll give you 5 minutes for that. See how we get on. Right, 5 minutes. Coming back at 11:40 with some lovely answers. And if someone wants to share screen afterwards, that'd be great as well. That's us at roughly 5 minutes. Has everybody managed to do something? And does anybody feel like they want to share their screen? Again, no obligation to do so. I can just talk you through the stock answers that Simon's created, if not. Let's have a look then. So the first thing you're asked to do is to create a new function that will calculate the mean of 3 numbers. So let's give it a name that tells us what it's actually going to do. So he's called it my 3 mean function, which is horrible, but does the right thing. And we're going to need to give it 3 arguments because we're going to work with 3 different numbers here. Within the scope of this function, it's going to create a thing called sums, which will be the sum of those 3 things. You could have just written x plus y plus z, same deal. And then it's going to create something called the mean, which is the sums divided by 3. And again, instead of writing 3 here, you could have written, the length of x, y, and z, or something like that. The last thing we're going to do is ask it to print the mean, this value that we've just created. So that will ensure that what we get back is the value for the mean. There'll be lots and lots of different ways of writing it. So let's now apply this function to the numbers 5, 7, and 10. So our mean of 5, 7, and 10 has come back as 7.33. Did everybody get something similar to that? To anybody have got something very different in the way that they set up their function or want to ask about their own methods? Good, probably means you're all on the right tracks. Stop me at any time if you're worried about it. Okay, and then we said create a function that calculates the mean over any set of numbers. So the way he's done it here is created a new function called my mean any function. And we only give it one argument here. We're only going to pass it one thing. And that one thing is going to not be a single number this time. So it's going to be any 3 numbers that we want to give it. So we're going to create the sums element of this function, which is the sum of all of those things in that vector. We're going to count how many elements that vector has using the length function, which we haven't seen before, but length does what it says in the tin. It tells you how long that vector is, how many bits it's got. And then we're going to calculate the mean as you would do with geometric mean by doing the sums divided by the number. And then again, we're going to make sure we print it out. So as long as we're passing x as a set of numbers, we can apply our function to any set of numbers. So here we've got a concatenation of the numbers 1 to 5. So let's just run this and make sure it works. So we've got a mean, as you'd guess, which given this set of numbers is 3, which is the mid value. We could have had this be a column in your data frame. We could apply it to the columns and we would get the mean of the columns because all it'll do is take each column as a vector, count how many things are in the vector, sum them all, and calculate the mean that way. How does that sound to people? Sabrina?
Just a quick question. So in the function where you say the sum and the number and the mean, the numerator, can you just put that into the mean?
What do you mean?
Can you just say, so when you say mean equals sums divided by num, can't you just say sum x divided by length? Yes. Okay.
Yeah. So what
is that bad practice or?
No, it's just different practice. So there's always a balance between being really verbose and writing out everything so that you know exactly what's happening, and it being nice and short code. So it's whatever matters. So what she's meaning there is instead of having sums is and then length is, what we can just do is have the mean is sums over length of x. So yeah, and then we would get rid of those and we'd have one fewer rows to deal with within our. That's what you mean, right, Sabrina?
Yeah, yes.
Yeah, that's absolutely fine. And the more you squish things together like that, there'll be less code, there'll be fewer lines, but you do lose something if you are trying to read it as a human coming to a new function. In this case, it's probably fine either way, you get the point, but especially if you're also going to use this value in multiple different places within your function, it's sometimes easier to assign it to something so then you don't have to keep repeating if this ends up being quite a large thing. that bit of code. Again, it's about not repeating yourself and making sure it's readable. But yes, you absolutely can do that.
Yeah, great, thanks.
Any other questions? That was a good question. Okay. Right then. It's not just data functions. This is not well written. So we can set up a plot to be a function as well. I've done this in some reporting work where I wanted to make the same plot loads of times, say for loads of different local authorities. You want to create a map for every local authority or whatnot. Rather than repeating the code for the function over and over again in your script, you will just write a function that will take any data and create a similar plot, but with those data for that element. So we're going to work with our SPC chart again with the plot the dots package and set it up the way we want it and just change it by site. So let's see how we would do that. So we're going to make a new function called plot site. And this is going to take one argument, which is we only need to give it a site. It knows everything else to do. Okay, so we'll give it a site. Within it, we're going to do all of these things within the scope of this function. So we now want to create a for each attendance type. So within the function, we create a data set that is going to only pull the data out of the big data set that we want for that site. So we do that by doing a filter. So we're going to create data SPC. Remember, this data SPC element won't exist outside when we run this function. It'll only exist for the length of time this is running. So it will know what data SPC is within the function and not outside. Go to the data and take the rows where the organization code equals is exactly equal to the site that we have passed to the function. And then turn our PTDSPC into an object. So we'll create plot SPC where we take that data we've just created, we run the plotting function with the specifications that we had before. We're going to again use the attendances values. We're going to use the period column. Again, direction is decreasing is a good thing for this time series, and we're going to facet it based on the type, which again was that 1, 2, and other. So for every site one we want to set up, we're going to do these same things. And when we want to return it, what we want to return is that plot SPC passed to the ggplot function, the ptd create ggplot, with some of the specifications we had before that made it look a bit nicer. Okay, and then that ends our function. So we can just give this plot site function a site name, and it will go away and do this plotting for us. So let's run the function, and again, nothing will happen when I run this function when I control enter on it, because all it's doing is putting that function into our memory so we can use it now. So let's apply it to a site, RJ1, for example. It's going to have a thing, and let's just open this up, and there we go. We've got a faceted plot based on type for each of the different types for this particular site, the RJ1, and we can do it for anyone. So RDD must not have had any other types within it than type 1. So it's only given us this one plot for type 1. So you can see that you could then start doing clever things like looping over all of the sites and creating the relevant charts for each one with one line of code after you've set up your function. And it'd be a really nice way to create a controlled chart like this for every variation that you need. So it's good practice for a function to not call on anything outside of the function. So you don't want the function to use anything that exists in here, ideally. And what you're going to see is, yes, in this instance, we are calling in the data, which is a data set that lives outside of the function. It can cause issues doing this because, again, it's all about the scope of the function. The things that we see in this environment pane here are what's in what we call the global environment. So there's a local environment, which is, again, sort of like the same of this thing as the scope of the function. And we don't want to be mixing the two up. We don't want to be always creating things into the global environment. We don't want to have to call things in from the global environment for our function to work. It can cause issues. We won't go into why and how and when, but you will run into issues with it if you start doing that. So the best practice, this can cause issues, especially if we later change something in the data. So best practice is to feed the data into the function. We can set it to a default, but this allows us to change it later without a problem. Or to point it to another data set if we want to, without having to copy the function. So here we're doing this. So we're creating our plot site function again, and we're going to specify site defaults to RJ1. So these are the defaults. We don't have to specify these necessarily, but we will need an argument of site, and we will need an argument of DF, which is shorthand for data frame. And in this case, we're going to use data. So this is where we set the default data set to data. But if we wanted to pull in a different data set to plot from, we could just give the second argument to the function as a different data set. We now want to create for each attendance type. So this is where we are pulling in our data. So data SPC is, we use DF now because this is the argument that is going to be the second argument to this function. So we take whatever data frame it is that we have said to use, and it does all that stuff we've talked about before, it does all that plotting. So let's run this. Let's plot site RJ1. It's bigger. There we've got our nice RJ1 plot faceted by type. We've now got a nice facet plot for a single site, but now I want to create the same plot, but over a number of sites, or even all the sites. Of course, I could just call the function over and over again. But what if there's a new site or a site is removed? I then have to keep a curated site list, which we don't really want to do because we're very lazy as data scientists. So the same function, but with added docstring. Okay, so he's put this in here to give us all these elements of a function that we need to understand what it does. And it's talking here about assuming that you loaded in the data frame called data that contains the relevant column names, then you can carry on like this. So it's the same function, he's just put in a lot of information here to make sure that it's clear for you. So when we finish this course and you're going through this work again to make sure you understand, read all these bits as well, make sure that they make sense to you. We won't go through them bit by bit today because we don't necessarily have time. Okay, so in that way, we can pull in a data set each time. We don't have to say within the function use a particular data set because somebody might have those data but have named them something slightly different, then your function will fall over. So having a data set as one of the arguments means we can always pull in the right one from the environment if we need to. Okay, any questions? Lovely. Okay, let's move on. It always seems strange to me that we go into functions quite deeply there and then we sort of pull back a bit and go into for loops, but a lot of you will work with for loops or have done in other languages. Can you quick thumbs up if you know what I mean by a for loop, just to see if we've got some understanding in the group. Yeah, a few people have used for loops. Good. Okay, a loop is an element that repeats a portion of code the desired number of times or up until something is evaluated. So let's look at a simple sequence. So seq is the base R function for doing a sequence. And as we know in R, if we give a range of numbers separated by a colon, it will use all the numbers in that range, unlike Python, which won't use the top one. So let's run sequence 1 to 10. This gives us the numbers between 1 and 10. We want to print out the sequence number plus 5. So we want to plus 5 to each of these elements. We can make a loop to do this. And the way we write for loops is this syntax, which luckily when you're using RStudio, colors these things nicely so you can keep an idea of which element you're working on. So for, given that it's for loop, then curly brackets for, and we've said here I, so for each element is an iteration, okay? And we often say for I as a shorthand for iteration. You don't have to use I, you can use anything. But in this case, we're using for each element in the sequence between 1 and 10, do something. And the do something is again presented within curly brackets to show you the scope of it. Okay, what will happen is R will run the loop for the first iteration, which will be number 1, as we can see down here. I will be 1, and then it will jump to the next iteration. So it'll keep going for all of the iterations in the sequence 1 to 10. So for each one, what we want to do is we want to create something called I plus 5, where we take the value I as it is at that current iteration, and we add 5 to it. The result creates a sentence where we stitch together these things with the paste 0 function, and then we print that result to the console. So let's run this and see what happens. So we've got 10 iterations because we have 10 we've got 10 iterations because there's 10 things in this list. So it starts off with 1, so it counts up by default as well. So I starts off as being 1, and therefore when we evaluate these with I being 1, we get 6 for this. And we've stitched together this into this sentence that says 1 plus 5 equals 6. 2 plus 5 equals 7. 3 plus, and it's going to keep going until it's run out of iterations. And given the sequence length up to 10, that means we've stopped at 10. Okay. Then with the curly brackets and scope. So a for loop does have global scope. So if you look for I plus 5 in the environment, it now exists out here. Okay, so this is a subtle thing that you'll forget sometimes, and I often do as well. When you're writing functions, the global environment is off limits-ish. You can still work with it if you really need to, but it's bad practice too. For loops do interact with the global environment. So I plus 5 now exists in our global environment, only with the last value that was seen. So I was, in its last iteration, I was 10. So the result, which is what it gets printed out, was 15 at last count, as we've got down here. And it was overwritten each time the for loop iterated. So we can mess about with sequence to come up with all sorts of sequences. So sequence takes a starting number, an ending, actually, what does it take? Okay, on it. Starting number, an ending number, and the third argument you can pass to it is how big a jump. So here we're saying start from 50, go up to the number of rows that exist in the data frame called data in jumps of 500. Let's look at what that looks like. So the last jump was 12,550 because data must be slightly bigger than that. Data is 12,765. So we're going from 50 in jumps of 500 all the way up to the number of rows in the data. The real magic starts when we feed in a vector of data. And we know that a vector, you can think of a vector like a sort of free floating column. It isn't, it's just a sort of, it's what we would in common parlance call a list, but a list has a special meaning in ours, so we don't try not to say list. So a vector of some stuff joined together. Here we've got 3 names joined together, concatenated, combined, whatever, into something called vector. So if I call vector now, it will give me content of that, which is Bob, Pete, and Mary. So let's iterate over this vector. So for I in vector, so for each iteration in vector, vector has 3 things, so it should do something 3 times here. Result becomes a paste of hello to the value of I that we're on, and it will print that result. So hopefully you can guess what will happen when I run this. I won't ask you, I'll just show you. So again, we're going to now iterate over the names. First one was Bob, so it first says hello Bob, then it says hello Pete, then it says hello Mary. Hopefully that was what you expected it to do. And we can see that result exists over here in our values pane as well with the last iteration that it was, which was hello Mary. So we can start iterating over. And just to prove the point, we could have said for each name in, let's call this list of names. Okay. Ooh, 2 L's for some reason. List of names. So let's iterate over the name in list of names. I like to give the iteration instead of I often give it a word that means something more to me. So if I'm iterating over local authorities and producing a map, which is the example I said earlier on, I would use for local authority in list of local authorities or something like that to make it clear to me. But everywhere that we had used I, we'll now have to use name. But it will do exactly the same thing as long as I've created a list of names and run it. So it'll do the exact same thing. So again, with a for loop, we're giving it the iterator in the bunch of iterators that you want to go over and then doing something. Okay. So now we can look at running our function, but within a loop. Almost, oh, we've got a question. Lauren.
Sorry, this might be a silly question, but I really struggle with naming things often. So am I right that name is just a word here? It's not related to list of names in a special way?
No, you could have called it anything. Brilliant. I like to call it something that makes sense if you were going to say it in English. So I want to iterate over all the names in the list of names. So I say for each name in the list of names, do something. But by default, you would use for I in, just because that's, well, you don't have to at all, but that's that's kind of standard practice. Okay.
Yeah.
You're right, naming things is hard. So let's look at running our function within a loop. It's almost that simple, but we need to recall that a function can only return one result. We would really like to collate all of those results into one object. You do that using a list object. So you know earlier on I said that a list is a special thing in R. So it's a super special multi-dimensional thing that can contain a mix of things. So a list doesn't have to all be of the same class, of the same type. So it doesn't all have to, you can have a list that's got some things are numbers, some things are data frames, some things are plots, some things are functions. It doesn't matter what's in it. It's just a collection of stuff. And so that's quite powerful. So we cannot create a list from within our loop. Otherwise, we would be creating it over and over again, blank on each iteration. So we make the list that we're going to populate beforehand. We initiate the list and we'll call it plot list. And we're just going to create an empty list. So do that with that line of code there. Again, we're going to go back to having something called vector, which this time is going to be 3 different organization codes. So we'll set this up outside our loop as well. So those things will exist in the environment, not just for while we were running it. So here we've created a little for loop saying for each element in vector, each of these 3 elements, do plot list function that we had. So plot list at that iteration level. So let's remember back that the square brackets after an object means for that element within that object. So for the ith element of plot list is going to be plot site at I. So we're going to create a plot that is to do with that element. Okay, that's kind of complicated. I'll maybe say that again. Let's run it first and see what happens. So this is, okay, let's do this and this. Have we still got plot list? The plot list at I is plot site. Do we still have plot site? Putting object is not possible. Okay, there is an error here. I'm trying to figure out what it means. It doesn't like our plot list. This is the way that I would usually set this up. Interesting.
Someone in the chat earlier, they had to go. They said that they found an error right here. I think if you scroll back in the chat, they said they corrected it somehow.
Yeah. Did he correct it in the chat? That would be useful. He did. I don't think he did he?
I think he did.
Oh, he did in the chat.
It was Samuel, if you scroll back at 10:15.
All right, yes. Okay. Oh, well done, him. Isn't that lovely that somebody's answered my question for me? So why have we had to use double brackets here? So the single brackets are usually finding us a position within an object. Okay, so the ith position. The plot list at I don't actually know why we've had to do that. Let's just double check that it does work though. It's quite happy with that. I'm not completely sure, to be honest, why it's wanted double square brackets there. Double square brackets is often because if you've got a multi-dimensional list and you want to take from the first element the x element of that, you know. So I can't tell you why right now. I'll Google it. I'll figure it out. So let's run this and see what happens. So we're going to run plot list for RQM to convince ourselves that that will create a plot, and for RJ1. It's also possible to call the plot from its position in the list. So the plot list of number 1 is now the plot list for RQM because that was the first one in our vector element. Okay, so let's just say, for example, we wanted to run across all sites in a dynamic way. We could create a vector of all the site names from the data. Again, we used the unique value yesterday. So we could use unique, we could use distinct, which is from a different package as well. So all of the organization code entries from data that are unique is now going to be what vector is. So let's convince ourselves of that by running vector. And again, we've got all of these horrible organization codes. I didn't know you could have really long organization codes. These are odd. Okay, there's 274 long. So we're not going to run this and create a fast SPC chart for all 274, but you get the point, okay? That you can do this and very quickly create standardized plots for all different combinations of the data that you want. And that is a thing that I find people do very, very commonly. And you can make sure that this goes into your quarter report. So again, If something changes in the data or in the background or in the list of things you want to iterate over, you can change all that without having to do anything manually. You can just change it once in your function and rerun the function, and it should work. Okay, guys, we made it to the end. Well done. And it's not even 1 o'clock, it's 12:05, which is great. So, are there any questions on the stuff we covered over in this last little part? Is anyone quite intimidated by functions, or anyone quite happy to start having a go and building some little baby ones? Or any reflections on anything we've done over the last 2 days? Oh, actually, Lauren, you had sent some questions, hadn't you? And I went away and asked. So the questions that Lauren asked, perhaps you can come off mute and say them again, but they were to do with factors, weren't they? About how we can create factors more dynamically, as Simon had mentioned in the text of this script. And what was the other one? I've forgotten.
So yeah, the factors, just because I have struggled and I found a way to sort of work it in a really not great way. So if there's a lovely, elegant way of doing it, I'd love to know that. And my other question was just around, like, I've definitely tried before to use across, because I feel like that was introduced to a lot of functions kind of after I'd started learning R, and just getting my head around to try and get it to work. I've quite often abandoned and just gone back to the way I know, or done it a really longhand way because it doesn't work. But that example where you're dynamically naming the output from across is probably the bit that I just needed someone to go through. So yeah, I'll go away and see if that helps.
Yeah. I'm going to bring up the help for that just now so we can see it. So there's lots of examples down the bottom of the help file for the across function. It is one that I struggle with as well, actually. There's ones that just don't really work in my brain, and map to and across, and some of the other per package ones are really tricky for me. So I find myself in the examples quite a lot and reminding myself what we're doing. So have a look here and it'll give you, so the iris dataset is one that comes as standard. So you've got that dataset so you can run these at home. And you can see the different ways that you can apply across as well. So you can see that you can apply it with a combination of actually named columns, or column name positions, or this kind of thing where you've got a range from the first position to the one called sepal width. And then you can combine the real powers where you combine it with where, and therefore you can do for all of the columns where there's double. So I would suggest having a look through these. There's lots and lots of examples here, and actually running them locally as well to make that. I'm not going to have any other examples that are as clean and nice as these ones. You'll see though they've used the old pipe, but it doesn't matter. So across predates the pipe, apparently, the new pipe. Well, I didn't know that. But for your other question, so I got Simon, actually, who was free, which was good, to give me some code that he uses to do some of these things. So here's an example where we've loaded tidyverse first, and he's set up a data frame or tibble with 3 columns: employee, activity, and region. So either cutting the grass in October, I don't know. So employee is these names, so it's a sort of character column. Then we've got a numeric column and another character for region. So let's create a new factor column called performance that's going to be based on this activity numeric column. Take the data frame, you mutate, ignore this bit about cut. Something called performance, which is a factor that we did before, where again you've got a case when that is defining per row whether that is evaluated true or not. If activity is more than 20,000, it's excellent. More than 10,000, it's good. If it's anything else, it needs improvement. And then within that you specify the levels in the order that you want them to be. So you can do this while you're creating the factor, so that you don't have to do it later on and do it multiple times within the different plots and whatnot. So this is quite similar to what we did, but it's another example therein. Then we've got another example down here of how you can add a new factor level. I don't know what your approach has been, but this is what he gave me. So here he's creating a data frame that's again got 3 different columns. These are now the numbers 1 to 4 for the ID column. There's a category, which is a factor with only the levels A, B, A, and C that exist within it. This is not in order. This is actually in row 1, it will be A, in row 2, it will be B, in row 3, A, and then C, and the values. We can use mutate. Let me just further up the screen. We can use mutate to create the category as a fact expand of the existing factor And what we're doing there is we're passing it which is the column that is the factor that we want to expand. And we give it then the level that is new to us. So as you were saying in your lab scenario where like you get a new assay and whatnot, and you need to be able to add in a new factor level, this is a nice way of doing it. So the fact expand is probably within, yeah, it's within the forcats package. So there's lots of different stuff in the forcats, which is for categories package, and fact expand is the way that Simon does it, which is a nice easy way. I think it's quite clear as well, and there's lots of different functions in that package that might be helpful to you. Does that look similar to how you would handle it on your side, Lauren, how it's been working on your side, or is that new?
So that's new, so that might be useful. What I end up doing is essentially pulling out all the unique options of whatever the variable is, so test names at the start, and then putting them in alphabetical order, and then recreating the factor, so kind of putting everything back to character and then back to factor.
So this might be a nice way to shorten that a little bit and to do it once and once for all. It is awkward, isn't it, that you'll get new things and have to add factor levels. It's a peculiarity of factors that we need to do that, but they have real benefits as a data type that come into their own when you've got really big data, really messy data. So hopefully that's useful. I will, where will I put this code? I'll create this code into a proper little script as well and put it somewhere that you guys can grab it from our repos, so that you've got it as well, and you can have a look at it. Okay, let me just check if there's been any other questions. Thanks, Ella. Oh, she's probably gone already. Never mind. Right, any other questions? Anyone want to bring up anything that we've covered over the last few days? I'd be equally very happy to hear if we didn't cover something that you were hoping for. So is there any other element that you would have expected to be taught in an intermediate R course that we haven't covered? We're always looking to improve these courses and make sure that they are meeting the needs of the people that turn up. So you will be getting a feedback form at some point from us via email. It'd be really, really, really helpful to me if you would fill that in completely honestly, of course, and say all the things that you liked, all the things that you didn't like. Lauren.
I'll probably forget this later, so I'll say it now. So the thing that I've struggled with several times with kind of functions and multiple outputs. So I've done something very similar. I've wanted to create a graph for lots of different analytes and output it for different date periods, but was the kind of outputting it with something named and either then being able to put that in a report or to save it somewhere. And I did manage it, but I guess, and it might be beyond the scope of intermediate R, but something where you're actually kind of taking the list, outputting it with names, and maybe it's just working with a list and I just don't really understand how to work with lists properly yet.
Do you know what? It's a really good thing that you've mentioned that, because as we end this course, we're doing exactly that, aren't we? We're iterating over, but we're not creating named items that are dynamically named based on what they are. You can do that. That is definitely possible. It requires you to dig into something called what's the acronym again? Non-standard evaluation, which sounds really scary and techie, and it is a little bit. But once you've got the handle of NSE, you can do things like that pretty easily. I don't know whether it does. I think it probably would scare people a little bit within an intermediate course. But what we can do, if it's a common thing that people want to be able to do, then we can have some resources that sit there in the background showing you how to do that. I think it is quite a common thing, right? Understanding how to make sure that the elements you're spitting out are saved somewhere so that they can be embedded elsewhere is a common task. So what I might do, I'll put it in my notes, is write a little thing on non-standard evaluation on how you can do exactly that task. And what I might come back to you, Lauren, once I've written that, to see if it meets your needs, if that's all right.
Yeah.
I suspect it won't form part of this because we already spend 2 whole half days on this course, which is a lot, I feel. But it'd be nice if that next step is sitting there waiting for you if you want to take it, I guess. Cool. Anyone else? Any reflections, any questions, any worries?
I just want to say thank you very much. There's quite a lot that I'd seen before, but the new stuff was absolute gold dust. There's some really, really useful stuff in there. So yeah, thank you for running that.
No worries, you're welcome. We run these it more infrequently than the introduction to our courses, but we try to do them frequently enough. There's always a waiting list. And we're always on the lookout for little tidbits or things that you think should be in this course and aren't yet, because obviously we're just doing it essentially off the top of our heads as to what we found useful in our intermediate, our journeys. So any feedback about that is really, really helpful. And the gold dust bits are definitely worth, if you've got other gold dust bits that you know of and you would have liked to submit, then please get in touch and we can add those in. Ready?
Yeah, I just want to say thank you very much. One of the cool stuff I learned was the old school versus the new school, like in terms of the way you do your summarize. The script I was writing, I was using the old school, but immediately I saw your new school pattern. Yeah, it was quite handy for me to change some stuff which I was doing there. Yeah, like the pipe as well. I've seen that, but I was wondering why is a pipe is slash and greater than sign against the former pipe stuff. So I learned some new bits against the old school stuff I'm really familiar with. Thank you.
That's brilliant. That's really, really good to know. Yeah, I have to confess, I still do the old school way. So I'm old enough to be a base R girl, which is really bad. I'd love the tidyverse, I do love it, but it moves on quite quickly as well. And it's hard work, isn't it, to keep up with these things. So you pick and choose the things that feel right to you, and it's absolutely fine if your code works and you do the old version of something. That's absolutely fine as well. But I'm really glad to hear that you've picked up some extra things from the last 2 days. Sabrina, you came off mute. I wondered if you were going to say something or if it was an accidental off mute.
No, I was. Thank you. I really appreciate it, Claire. I've been away for a while, so coming back and getting a little refresher for R was really great because I think I did a lot of this stuff before I was on maternity leave, but kind of like dipping my toes back in again. But at the bottom of the script, you mentioned that some further courses. Do you have any idea if you're going to do some markdown courses or anything like that in the future?
Kaylee, if you're listening in, can you pop the links to the extra courses in the chat, please? So we don't usually run them like this, like sort of live courses. We provide them as the materials that you can go through by yourself if you like. The reason for that is for all of these courses that we as a community run, they're all voluntary, they're volunteer led. So our colleague that I've mentioned that wrote the script we've used today, Simon, does a lot of this training. We're always on the lookout for people to deliver them for us. So the NHS-R is only a small part of what we do. We all have day jobs as well. So running extra courses is a difficult thing for us to do, especially with the courses that are not as heavily subscribed as the introduction and the intermediate ones are. I know that we've got courses on Git, we've got courses on Quarto, we've got a couple of other bits and bobs as well. If there's a big demand for those to be run in person-ish, like this is, then we could look to doing that. Equally, I would say, as you in this room, your journeys with R continue, you get more comfortable and all the rest of it, please, please, please consider getting in touch with us and delivering one of these. So you do not have to know everything. You've seen me make mistakes today and code horribly. It happens, it's fine. We try to work on a not as desperate a way as we did when I was back in veterinary medicine, when it was a see one, do one, teach one approach. It's not that bad, but as soon as you feel like you can give back to the community, please do get in touch with the community and offer to put on a course or to co-pilot a course. So I've got Kaylee in the background today, who's an NHS-R person. We often have what we call a course co-pilot, which is just another person that's there that also knows how to code and can sit in the chat and answer questions and whatnot. You could be that co-pilot for a few times, and you could sit in the background while I'm teaching or whatever to learn the ropes and whatnot. And we give you all the support you need to do for that. Thanks, Kaylee. Those links are in the chat now for the different things. So we've got a Shiny for Beginners course as well. So Shiny is about building apps, which is really fun. Introduction to Git and GitHub. Is that one that you're thinking of?
Yeah, I'll mention it to our wider team because there's a lot of our experts in the NDRS team itself. Yeah, so I'll mention that as well.
You've got loads of Shiny people
as well. Yes, we do.
I know. Yes. I used to work for them, guys, so I do know who they've got. And Quarto, I think, is an underused tool. I think a lot of people are still using R Markdown, which is fine. It's still supported, but Quarto has got some extra bells and whistles that make it really lovely to work with. So if you have suggestions for new courses that you think we should be trying to put on as well, then do let us know. We're always up for that. And we can work together to produce a course that meets your needs. Right. On that note, because the leaf blower is now coming back, I think I'll let you go. So hopefully you've got all those materials, free to go over them at any time, go back to them. I'll pop into the same repository that extra script that has those bits about factors for you, Lauren, and anyone else who finds that useful. Otherwise, keep a lookout for the feedback form, and please get involved with the community anywhere you can. So thanks very much for coming, guys. Have a lovely day. Bye.